Good morning-ish, ladies and gentlemen. Wish you're here. It is Happy Virtual Monday. Hope you all are having a fantastic Virtual Monday. Just working those academic fingers to the digital bone, I'm sure. We're just having a great day here. My dog is having a super grumpy, loud, barky day just because she's apparently just an angry old lady right now. I don't know. So if you're yapping in the background, that's how we roll over here. I had gotten a couple of requests and promised to look at these Google Slide digital interactive molar conversions, which I'm still a huge fan of, and hopefully they've been helpful to you. Bottom line is that if molar converting is something that you're remotely struggling with, which is way more the norm than the exception, as I've mentioned, it is something that everybody gets to the finish line on. It's just a very dramatic spectrum of how long it takes, how quickly things click, and especially in this case, the way it's presented. This has proven pretty darn effective. I've already told you there's some specific things I love about this, in that it shows you, for instance, over here, this entire side shows you conversion factors, showing you that as you, number one, choose a conversion factor, there's just not that many to pick from. And all of the possible journeys that you can make and conversions you can make, there's only 3 essential conversion factors here. Comparison of moles to particles. Here they have molecules because that's possibly in the problem. Moles to liters if you're dealing with volumes of gas. Moles to grams if you're dealing with molar mass. Pardon me just 1 second. I'm going to shut the door real quick here. I don't know what she's afraid of. That won't perfectly do the job, but it will help. So glad you got to be in on that process. Anyway, first, having you choose between a very small number of set conversion factors, so you can see it's not magic. There's not a million of them. That it's very, very small set number of relationships, just like 4 quarters to $1. It could be, you could have 4 quarters to $1 over here. You could have 12 donuts to a dozen. You could list them down the line and realize there's just not that many. So being able to see that that's the case and dragging them as a unit, because a lot of students, they look down here in the dimensional analysis grid and you see top bottom numbers and they think that something random is going on the top and random on the bottom. Or that you can move the unit and not move the number. So if you didn't like moles up here, you could, just move the mole down to 6.02 times 10 to the 23rd, the molecule up to 1 and not have any consequences. Not the way that works. It is a set unit of comparison and it has to stay together. So I love that part. And just making you analyze and realizing that these word problems, they make the problem here the smallest thing. And so it's surrounded by all this other work. And so I love the fact that, when you're learning how to do these word problems, and there's going to be so many, that they really emphasize it's not the problem that's the most important thing here. It's learning how to navigate it for this exercise that's most important. And I love that. But we still do need to solve the problem. So what I've done is I've chosen 2 problems, problem 8 and problem 6. Problem 8 is a 1-stepper. Problem 6 is a 2-stepper. I've chosen them both because they both involve liters, which we haven't done a lot of work with, but it really doesn't matter because hopefully, as you've seen, once you know how to do any of these problems, you know how to do all of these problems. All you have to know is how to dissect and define your destinations. So before I fly through them, just to do a 1-step and a 2-step with liters involved, I wanted to point out that here with particles, notice on your mole island sheets, I told you I don't like atom island on there because it implies that that's the only thing that you're converting to. But really, I like this much more because particle, remember, is a generic term for anything you want to count. So with the mole as our hub, the concept of the mole being the count that it is and the ratio it has to molar mass and the atomic masses on the periodic table, the mole has this distinct relationship to be able to convert us to a count. So particle represents, I want to know how many specific exact things are there. How many atoms, exact number of atoms can I count up? Ions is just a charged atom. So if Na, sodium, you have one sodium atom that's Na plus 1 would be an ion, a charged sodium atom, which means it's gained or lost an electron. It's just another kind of atom you can see. Molecule, and this is where we discussed a little, molecules and formula units, two different ways of talking about compounds. So real quick, that's the long part of just why I love this and clearing up. I've had a lot of questions about this yellow. Most people are cool with, hey, grams, what's the difference between grams and particles? This is how much stuff I have. If I give you a pile, I want you to know what's the weight of the stuff, okay? Moles can tell me how to figure out if I put a pile of carbon on your balance, you can figure out how many grams is in that pile if you know your moles, or vice versa. If I give you the number of grams, you can tell me the number of moles. Liters, I can't give you liters of gas on a balance in terms of grams, but I can give you a liter amount that's in a tank or canister, and I can convert the same way. So I have relationships to volume of gas, mass of any pile of anything I want to throw at you, and then a count. So this is Mole Island right here. So real quick, this is a single stepper. How do I know it's a single stepper? How many moles are in 0.77 liters of Br2? So I want to know, what am I given? I will go ahead and I will put in just the units. I'm starting with liters, okay? I'm going to shorthand that. What am I going to? My desired is moles. So I'm given 0.77 liters of bromine gas, Br2. Remember those gases that have they like to pair up. We have those 7 gases, bromine's one of them. So I have a volume of 0.77 liters of Br2. So step 1, do you realize that liters is volume? You should. So there we go. And it's right here, liters and volume. So I have liters and I want to go to moles. So I'm going to chart my path. That is the game that I want to play. Going to from liters to moles. So that is the path. How many arrows? That is one single sweet step. All right. So I have now dissected my problem and said, hey, I'm given liters, which is a volume unit. Hey, I want moles. That's my unknown. How many steps? It takes 1. How do I know? Well, for now, if I diagram it out, my journey, liters to moles, is a 1 step. Remember I told you, anytime you see mole in a problem, you're either going to the mole, converting, or you are leaving the mole and converting to something else. Those are 1 step, okay? If you don't see mole, that means you're having to go through it to another step. So then, next, I get down to my dimensional analysis grid, as I call it. They very kindly do 2 things. They set it up for me. So we always said top left. You put it up there. You want to put it over 1. There's not a little thing for me to, I could bring up a pencil, but I'm not going to worry about it. Remember, this is like over 1, 0.77 over 1, just so you know that 0.77 liters is on the top. So next I choose, well, I can do my, let's see, my unknown. I'm going to designate just to cheat and say I want my mole. my given is down there. So just to fill in, hey, there's my given, there's my unknown. So step one, I need to choose the conversion factor I'm going to work with. So how do I do that? I need to know the relationship between moles and liters. Well, they give it all to you over here. So obviously what I'm looking at is which one of these has moles and liters in it. Well, I've got 1 to 22.4 and I have 22.4 liters to 1 mole. Remember, those are the same. Mole-liter relationship is 1 to 22.4 moles to liters. So whether I put moles on top or bottom doesn't matter. It's just there so I can cancel a unit. What unit do I start with? Over here, I got liters on top. That means somehow I want to get liters on the bottom. So I'm going to choose the mole to 22.4 liter. That is set in stone. That is the same for every gas. And I'm going to choose this one and drag it down because that will let me cancel my unit. If I could bring my pen up, I would slash that liter out so you could see, hey, look what I've done. I chose the conversion factor, 1 mole equals 22.4 liters of every gas, and I drug it down so I had liters on bottom to cancel the liters random that I was given. There's nothing special about 0.77. So now, have I canceled my liters? Yes, because liters is on opposite top bottom. What unit am I left with? Moles. That's what's left behind. What did I want? Moles. So I'm done. So the only thing I have to do now is the math. So this is now set up. So your setup's complete. So that will be 0.77 divided by 22.4 equals 0.034. So I'm going to type in 0.034, and that's going to be, what's my unit? So 0.034 moles. Okay? So I want to know, am I right? What problem is this? This is suite number 8. I can go to my key that I posted for you, and I look at problem number 8. Whoop, there it is. Check it out. We are correct. So one of the many other things I love about this is the fact that they do the math for you. Now, I had to do my own math there. 0.77 divided by 22.4. However, if you'll notice over here, if it had been a mole to molecule conversion, I would have chosen either Avogadros over 1 mole or 1 mole or over Avogadros in terms of my count is atoms, ions, molecules, formula units. I didn't choose that because that wasn't any part of my problem. That's up here. Was I going there? No, I didn't have anything to do with that. The other option was molar mass, 159.8 grams to 1 mole. That is when they calculate the mass of 2 bromine atoms for me. So remember, molar mass, you got to count yourself. I love this because they do it for you. You don't have to do that. So while these are set and never change, Avogadros is always that number compared to a mole, and my volume is always 22.4 liters compared to a mole. But molar mass has to be calculated on the periodic table for every different substance. So I love that they calculate that out for you. So all you do is you drag the correct one and then you do the math. This was easy, 0.77 divided by 22.4. In your calculator, you could have said 0.77 times 1 divided by 22.4 equals, and you'd get 0.3034 moles. So however you want to punch it in, you're really just, remember, multiplying through the top to get your numerator, and then you multiply through bottom, get your denominator, divide them, but really all I was doing was dividing 0.77 by 24. So now real quick, as my time is running out, problem number 6. So clearly, this is liters to grams, okay, at STP. So first thing is I need to map this out. Well, what am I given? I know I'm given grams. Come on. Grams. What do I want? Liters. Now, let me chart it out. Where do I start? Grams. Here's grams. Grams up here, liters down here. I have to go through the mole. So first, I'm having the hardest time on this little pin. Bing! That is my journey. Done and done. So I have to first go grams to moles, then convert moles to liters. So this is a two-step necessity. Remember when I said if you don't see moles in a problem, it's two steps? Here you go. So I just charted out the fact that this is going to be a two-step problem. Okay? So you could say, most complicated you're going to do? Sure. Well, still, who cares? It's still the same process all the time. So they start me out 80 grams NO2. Okay? That's nitrogen dioxide. So the STP, remember, don't freak you out. That's standard temperature pressure. That's just their way of saying in normal conditions, here's how that works. So I need to pick my conversion factor that lets me go to moles, from grams to moles, because that's my first part of my journey right there. So what lets me do that? The gram-mole relationship. One of these two, otherwise known as molar mass. They've already calculated 46. How nice of them. So 46 grams per mole, or an NO2. 46 grams of NO2 is 1 mole. I'm going to drag one of these two over. They mean the same thing. Which one do I drag? I just drag the one that cancels my unit. So that is grams on bottom. Bing. So I have now successfully gone from grams to moles. That is done. I could slash and bash grams if I could possibly do it. Now I'm sitting at moles and I'm not done. I want to go liters. So now I'm just going to do another conversion. I don't need to start a new problem. I just need to drag another factor. So what's my mole liter? 22.4. Where is this one? Right here. Do I want liters or moles on the bottom? Well, I want moles on the bottom because I got to cancel that mole out on top. So all I've done is I have used two conversion factors. One is molar mass. That's different for every substance, but they counted it for me, so I didn't have to use a periodic table. Very nice of them. And the other is liters. Okay? So that is, notice I didn't have to use Avogadro's because I'm not doing a count. I wanted volume. It didn't ask for how many atoms, ions, molecules, formula units. It asked for liters. So I got lucky. No scientific notation. So now it's time to do the math, and that would be 80 times 22.4 divided, I didn't even stop. I could say 80 times 1 times 22.4. Divided by, I didn't hit equals, 46. And not just to be formal, I could show you, I'd hit divided by 1. 80 times 1 times 22.4. I'm not going to hit equals. I'll just keep going and hit divided by 46 divided by 1 equals 38.9 moles. 38.96. 38.96 moles. Now let me go quick and check. Yep, 39. They rounded it up for me. Sweet. All right, so that's just how I roll through it in the head. Remember, to me, the most important part is charting it out, dissecting it, and realizing that, yes, solving the problem is important, getting the right numbers is important, but the understanding and the setup of what was unknown in this case, I'm having a hard time. My given, being able to know, what am I given? Where am I going to go? What's my journey? It's a two-step journey, but it's okay. And that everything is just interchangeable. Every process is the same. It just uses a different relationship that you're just going to drag into place. And you're just going to make sure you cancel your units, and then you do your math. So yeah, are there a lot of places that you could oopsie it up? Sure. Except the process needs to get rocked on and rock solid. So that's how we're running into that. So we'll keep dealing with these questions as they come up, but just quick run-throughs. Well, not so quick because it's me and nothing's quick.